All right, welcome. Welcome to this video where we'll be looking at the maximum depth algorithm question. So this video will help you to at least understand to an extent how you should go around answering your algorithm question, and I'll show you how this particular question is answered and what you should focus on. All right. So given a binary tree, find its maximum depth. So the first question is, what is the maximum depth? And so the answer is immediately the maximum depth is the number of nodes along the longest path from the node from the root node down to the farthest leaf node. And a leaf node is that last node with no children. All right. Now, most times when you look at the question like this, it gets overwhelming immediately because there's so much text. In fact, this text is not so much, but you can get the one that you have, up to like 15 lines of text, 10 lines of text, and it becomes plenty. But what should be your focus? Your main focus should be on the example because that's actually what they want you to do. So let's go down to the example. In the example, it gives us the binary tree and tells us what they're expecting. So the binary tree is actually an array of numbers. It could be alphabets or whatever, but it's an array. And an array is a normal concept in programming that we all know. Now, the next thing you should look at is what result are they looking for. So they are saying it should return its depth as being equal to 3. So you now wonder why or how should that happen. Now look at the tree that was drawn. Now the tree there starts from 3. It now moves to 9 and 20. And then the 20 moves to 15 and 7. Now compared to what we have in the array. Now when you make that comparison, you notice that the first index of the array is 3, or the first value in the array is 3. Then the next two are content or indexes contains 9 and 20. After that, we now have the next 4, which is null, null, 15, and 7. Now, based on that, we can assume that the null should be the children of 9. And then the 15 and 7 should be the children of 20. Now, based on this understanding, what this means is that when we want to loop double whatsoever is the current number or current count or current node. So for example, the first node there is just a single number, and so the next looping we want to do, or the next iteration, should loop over 2 and not 1 like it did the first time. And after that, because we have 2 this time around, the next loop should go over double 2, which is 4, and so it should go down that way. All right. So having this understanding, let's now move to writing the code. I have already written the code and I ran it here a while ago. So let me clear the history here and gradually explain the code. The question is up here. I'll be leaving a link to this down in the description. But we're looking for maximum depth, so let's go into the function. And the first thing there is an array. So we're given an array. The first thing we want to do is we need to be able to keep track of how many indexes or how many parts of the array we are picking. So the first count is 1. Remember that the first node there, or the root node, is 1. So we are beginning the count from 1. And then the next thing, we need to be able to keep track of how many parts of the array or how many indexes we have been able to loop over. And so that's why we have this marks here. It keeps track of the visited indexes. And something else you need to note here is, because we are not asked any other thing, there is no other constraint aside what we are saying. We'll be mutating our array because we'll not be needing it at the end. But if there were some other constraint, we may not need to mutate the array. So since we don't have any other constraint, we'll mutate our array. And so we begin by iterating over the array. So what we are doing here is we want to keep moving from the first index of the array down to the number of number that particular tree or that particular node is supposed to take under it. All right. So like we said, the first node has just 1, and so our counter is set to 1. So in this first instance, we are doing our array.splice, and we're starting from the index 0 down to the counter, which is 1, which means it will take out only 1 from that array. So once it takes it out, then it is deleted from that array, and then we now have our array beginning from the second one. So this second index will now gradually turn to the first index. All right. After this, after we have already collected 1, we now want to collect more than 1 this time around. So how many do we need to collect? We need to make sure that we have the amount of we need to pick the amount of indexes that will fit double each under the current node. So let's go back to our tree here. Because we have 1 here, we need double, so that gives us 9 and 20. Now when we want to move further, we now need double, because each of these child node will turn parents to 2 other nodes. All right, so that makes it double. And so here we now multiply our counter, and down here we are checking this. Our loop would be terminated immediately we see that the counter is greater than what is remaining in the array. Once what is remaining in the array is now less than the counter, we will push it into like push the last part of the array into the max. All right, and of course this does not include when the array is empty. Once it's empty, we will not need to run that condition. All right, so once we do this at the end, we now return the max.length. Now the max has been able to keep track for us each of the index as they entered. All right, so let's run our code and see the results we get. We get 3. Recall that we are working with this, and the result we're expecting is 3. Now after this, we also have the second one. This is longer, and it gives us 5. Now for you to understand what's going on, let's log to the console the counter at every loop. So this is the counter at this point. Now we want to also log to the console the max. So this max keep track of everything, every index we have been able to gather. So for each of the loop, you see what happens, and that's an easy way to understand it. So let's run it. Great. All right, let me get rid of the second test here, so that it's easy for you to understand. So let me clear this. All right, so let's run this again. Good. So now look at what's happening. At the point where the counter began, which is 1 here, we were able to collect just one from the array and put it into the max array. Then the second loop becomes 2, because here it doubled, so it becomes 2 here, and then we picked 2 from the initial array and put it into the max. Now at every point, our array continued to diminish. Now for the last one, we also multiply by 2, and then we picked the last 4. Now because our array is now empty, this will never turn to true, so it comes here to try again. It turns out that this is actually equal to this array length, and so it terminates. And so we now get our final decision here, which is 3. All right, now there might be cases whereby the counter does not turn to 0 and the array does not turn to 0, something like that, or the array does not turn to 0, and so it's not equal to the counter. It's also not less than the counter. So that would be in our second case here. So let's uncomment that. Let's clear the console and run again. So at this case, we did the same thing. We had 3, we have 9 and 20, we have 0, 0, 1, 5, and then down here we now have 3, 9 down up to this place. All right, now if we log, let's do console.log, or let's just remove this length from here. Sorry, let's get rid of this length from here, and let's run this code again so that what I'm explaining is clearer. So we run the code again, and now look at the final max array. It has 4. Now why does it has 4? Because at this point it checks if this array length is less than the counter, because we have already increased it here. Now after checking and truly it's not less than the counter, and the array dot length, that is the amount of items inside of the array, is also not 0, then there's no need to continue the loop. It terminates at this point instead of continuing, so it returns at that point. All right, so once it does that, it comes back to here and check if this counter is less than or equal to this. I noticed that that's false. Sorry, that's true at this point, because array.length is 0, of course, so it terminates, of course. So that's why we now have array.length returning to 5, and that is actually correct. Now something else you can choose to do is, at any point this happens, you can choose to do this here, but make a return at this point. So return at this point. All right, so anyone works and it's perfect anyhow you choose to do it. All right, so that is it, and this is how to solve the problem of maximum depth. You can suggest other ways this could be solved. Please leave it in the comment section. I'd like to see. Let's interact and see other ways where we can solve the same problem, because of course there is no one way to solve one algorithm problem. Thank you very much for watching. Please subscribe, share and like. I'll see you in another video.